I am Juan-Juan, your Six Sigma instructor, and today we're going to discuss how to read and understand a Minitab Sixpack Report.
Juan, before we start, can I ask you a question?
Sí,
Do you like music?
sí, I love music. Actually, my favorite group from the past is One Direction.
Nice, but what about something more contemporary? Do you like Taylor Swift?
Oh, sí, I love Taylor Swift and I love her songs.
Which songs?
Well, songs like Shake It Off, Welcome to New York, We're Never Getting Back Together, and many others. But do you know which ones are my favorite songs?
Which ones?
My favorite songs are Two is Better Than Juan, and of course, the Juan. Anyhow, let's talk about the Minitab Sixpack Report. Welcome back. The Minitab Sixpack Report is divided in 6 panels or charts, hence the name Sixpack. 3 of the charts are focused on process monitoring, which are the individual chart, the moving range chart, and the chart containing the last 25 observations. The other 3 charts are focused on the process capability, which are the capability histogram, the normal probability plot, and the capability plot. Let's review them one by one. Remember, this video is about how to read the report. To learn how to create a report, please check my process capability video. Before we go over each chart, let's discuss some general features. Let's start by opening the report. To do that, double-click on the report, and if you prefer, maximize your screen. A very helpful feature is that if you move your pointer to any individual point on the chart, you can see the actual value of that point. You can also edit the labels on any of the charts. Just double-click the label and the editing screen opens up. Make the changes you want and click OK. Lastly, you can also add notes or symbols by using the editing toolbar on the top. Now, let's talk about the charts. The first panel is the individual chart or eye chart. The center line represents the mean of the sample, and these lines are upper and the lower control limits. Minitab calculates the control limits using this formula on the top, which basically is the mean or average of the samples plus and minus 3 times the standard deviation of the sample. You can have Minitab to calculate the control limits in a different way if you want. If, like in this example, you see a red point of data, that means that the point is out of control. In other words, the value of that point is beyond the 3 standard deviations, but that doesn't mean that the process is out of control. No. This only means that the particular point is out of control. So you may need to investigate what happened. Maybe it's a bad reading or a temporary issue in the process, or maybe it's indeed one point out of control in your data, which may be okay. Because as you can see in this example, the process is centered and within the process specifications. So that red dot is not affecting your process. You just need to find out what happened. The second panel is the moving range chart. Like any other moving range chart, Minitab creates the chart by subtracting the values of 2 consecutive points from the previous chart. You can also change the range to 3 consecutive points or more if you want, but by default, Minitab calculates the number by subtracting only 2 points. The third chart is the simplest of all and only charts the last 25 points of data from the eye chart on the top. Now, before we take a look at the capability charts, let's take a short break. The next panel is the capability histogram. In this graph, we can see the data distribution. These lines are the upper and lower specification limits, either from the print or the process specification. The red curve represents the best fit normal distribution, taking into account the mean and the overall standard deviation, the standard deviation of the population. If you point to the curve, you can see those values. The blue curve represents the best fit normal distribution, taking into account the mean and the within standard deviation, the standard deviation of the sample. If you point to the curve, you can see those values. The next panel is the normal probability plot. This graph will let you know how far or how close your data is from a normal distribution. If the data points follow a straight line, that means that the data is normal. But if it doesn't, like in this example, it's better to look at the values above. The p-value, as we know, compares your results to the significance level. The Six Sigma explanation is that if the p-value is equal or smaller to the significance level, that means that the data do not follow the distribution and we need to reject the null hypothesis. In this case, the null hypothesis is that the data follows the normal distribution. Oh my, I have a headache. Or, in simple terms, the p-value is less or equal to 0.05 or 5%. The data is not normal. In this example, the p-value is 0.024, which is smaller than 0.05, so the data is not normal. And you can see that in the histogram too. The data does not follow a normal distribution. On the other hand, if the p-value is larger than the significance level, we cannot conclude that the data do not follow the distribution, so we fail to reject the null hypothesis. Oh, me duele la cabeza. Or in simple terms, if the p-value is larger than 0.05 or 5%, the data is normal. In this example, the p-value is 0.694, which is larger than 0.05. So, the data is normal. Let's take another break. The AD value is defined as the Anderson-Darling goodness of fit statistics, and it is basically a number that tells us about the deviation between a perfect normal distribution represented by the straight line in the middle and the line created by the data points. I will create another video to analyze this concept deeply. For now, I will tell you that there is no magic number for the AD value, but as a rule, a larger number is telling us that the data does not follow a normal distribution, while a smaller number means that the distribution is closer to normal. In this example, you can see that the distribution is not normal, and the AD value is 0.861. While in this example, the distribution is closer to normal and the AD value is smaller, 0.258. Remember, larger ID, not normal. A smaller ID, normal or closer to normal distribution. Let's take an aspirin for the headache and let's review the last panel. The last panel is maybe the most important on the report since it's the one that gives us the values of the capability indexes. On the left side, we have the indexes that are calculated with the standard deviation of the sample or the standard deviation within. Here is the value of the standard deviation, the CP and the CPK. The CP calculates the dispersion of your data versus the specification limits. For the CPK, please watch my capability video. Also, here we have the potential ppms, which is the number of defective pieces per million produced. On the right side, we have the indexes that are calculated with the standard deviation of the population or the standard deviation overall. Here is the value of the standard deviation, the PP and the PPK. The PP also calculates the dispersion of your data versus the specification limits. For the PPK, please watch my capability video. We have one extra index on this side, which is the CPM. The CPM compares the spread of the data versus the specification limits. However, you need to have for this a target value. In this example, I enter a target value of 1.24 on the options screen, and the CPM value is calculated as 1.42. Also, Minitab displays this line on the histogram above to show where the target value is. And here we have the potential PPM, number of defective pieces per million produced. Lastly, the charts in the middle display the mean, the control limits, remember, mean plus 3 standard deviations, and the horizontal line represents the total spread. The graph at the bottom displays the specification limits, so you can easily compare your distribution versus the specification limits. That concludes the review of the six-pack report. Now, let's go to the final thoughts. And here are my final thoughts. Minitab six-pack reports have become the standard reports for capability studies, especially if you are in the automotive industry. So try to learn them, use them, and understand every single detail about them. But be careful. Remember that capability studies only measure process variation, not part quality. So don't make all of your decisions about quality or inspection points in your process based on capability studies alone. No. Always consider gauges, vision systems, and inspection equipment for your process.
Juan, before we leave, can I ask you another question?
Sí.
Are you really a Swiftie?
Oh, sí. I am the Swiftie number one. But you know what is the difference between the other Swifties and me?
What is it?
Well, the other Swifties are very nice people.
And you?
I am bad blood. Well, that's it for today. See you next time. And until then, take care of yourself and each other. Mimi, let's shake it off.